Hi everyone, I'm Xinyue and here today I'm sharing my recent work prompt scaling attacks against text-to-image generation model. So this is a new kind of attack in the ecosystem of generative AI. And this is a joint work with my colleague Yiting and my advisors Michael and Zhang. So to start this talk, I want to first show you some gorgeous pictures. So you can see that they are in very different styles, right? And also in very different types. Of course. So here we have audio painting, we have game page, book illustration, magazine cover, and also game asserts. So actually, all of these images, they are generated by text-to-image generation model. And as you can tell, text-to-image generation model has already been widely used in industry across multiple domains. So how does text-to-image generation model work? This is not a key point of our paper, so here I just put it simple. So to use text-to-image generation model, you need to first prepare a description of the expected image, which we call prompt. And then the model can automatically generate the image based on the prompt. But this process is not as simple or easy as you think. It's not something just out of the box, right? So, for example, if I want to generate an image like this, as a normal user without any art background, I just look at this picture and I type a tree house in ancient forest. So what will I get? Images like this, or this. Yeah, they are beautiful, but far from what I expected. So this unstability is actually unacceptable in industry, and unfortunately, this is not what generative AI is good at. So generative AI means random, a lot of random. So if you really wanna get the picture on the right side, what does the prompt look like? It looks like this. So in the measurement part of our paper, where we collect and analyze 61,000 real-world prompts from end users, so we find a high-quality prompt. It usually contains two parts. The first part is subject, which will describe the main object in the image. And then the second part is modifiers, so which describe the styles of the image. And we then combine the subject and modifiers together and the prompt, and then send to the text-to-image generation model. Now, we can get this beautiful picture. But if you look at this prompt, you can see that there are lots of other words, right? Like the trending, artist names, media, movements, flavors. So you might want to ask, how can normal users like us come up with such a complex prompt? Yeah, I can confirm it's really a very hard task. So this leads to a new profession, prompt engineer. So here's a story of a prompt engineer, Anthony. One day, Anthony wants to generate an image like this. So this image only exists in his mind, right? So Anthony wants to reproduce this image in the real world by the text-to-image generation model. So what should he do? Still, Anthony starts to describe the subject in the image. So here is a mermaid, and he sends this prompt to text-to-image generation model. Here's the results. So it's very different from what he wanna get. But it's okay, no worries, we can fix it. So he tried to add more modifiers based on his experiments. So he can restrict the painting style, which we can see that is a watercolor illustration, and results become better. And he can do more things, like he can add more modifiers, like he can set the atmosphere, the background, and the effects. You need to try lots of combinations to figure out the right prompt. So after several days hard working, finally, Anthony got this, figure out this prompt that can be used to generate this image in his brain. So Anthony is actually so proud of his prompt, and as a prompt engineer, he sells his prompt on the prompt marketplace. So this is the selling page for the prompt. You can find the introduction, the price, the images generated by this prompt, and many other information. So Anthony asked $2.99 for this prompt, and he has already sold out 6,000 prompts. So in other words, this prompt has brought Anthony 18,000 income. And Anthony's story is far from unique. So there are thousands of prompt engineers like Anthony right now. Based on our estimation, on the top 50 prompt engineers, 45,000 prompts has already been sold out in 9 months. And in total, it corresponding to $187,000. So there are also lots of prompt marketplace appeared. So given such a new and increasing ecosystem of the generative AI, as a security researcher, we wonder whether it also brings some new problems. Like, for example, giving a generated image shown on the Xinyue web page, whether an attacker can infer, or in other words, reverse engineer the corresponding prompt. We name this attack as prompt stealing attack. Okay, let me introduce our 3 scenarios again to be more specific. So first, the prompt engineer produced a high-quality prompt, which we call it target prompt. And the prompt engineer uses a target prompt to generate a target image. And the prompt engineer can submit both the target prompt and target image to the prompt marketplace. If a user is interested in the prompt, he will buy it. So he can use it to generate some images. And if an adversary is interested in the prompt, he will use some techniques to steal the prompt, so based on the target image. So we call the inferred prompt as stolen prompt, and the images generated by the stolen prompt as stolen images. Okay, now we move to the attack methodology part. Giving a target image. If we want to get the stolen prompt, what techniques can we apply? The most straightforward word is to use a generator, right? Like an image captioning model. For example, if you give this cat image to the model, then it will output a sentence, a cat wearing sunglasses. And you can also click some dataset to fine-tune the model to make it perform better on the distribution of generative images. So we tried both ways, but the performance is not that satisfying. I will explain it later. So we come up with a new method, which we named as PromptStealer. So PromptStealer is inspired by our findings in the measurement part, as the subject and the modifiers are both important. So we tend to solve this problem one by one. So first, for the subject, we use a subject generator to obtain the subject. And then for the modifiers, we use a modifier detector to predict the modifiers. So basically, it's a multi-label classifier. And but because previous traditional multi-label classifiers, the labels are objects like cat, dog, water, so they are not modifiers. So what we do is that we replace the head to change the prediction to modifiers, and then we use our collected data set to fine-tune both the subject generator and also the modifier detector. So this is a basic framework of PromptStealer. Yeah, and now we move to the experiment part. So we use Stable Diffusion for most experiments because it's free. And we consider 3 baselines as 3 methods as the baseline. They are an open source image captioning model, BLEEP, and a fine-tuned image captioning model, and also BLEEP interrogator. And during our experiments, we actually find it extremely hard to measure the similarity of the images and the prompt, because it's not pixel level differences, right? It's, you need to measure the art styles. It's very hard. So we try our best to provide an evaluation as comprehensive as possible. We use 5 quantitative metrics and 1 qualitative metric across the semantic, modify, image, and also pixel level similarity, and also has some human efforts to annotate the quality of the image. So here's the results. This is the 2 target images and the corresponding target prompts. And here is the performance of the 3 baselines, and this is the performance of PromptStealer. So you can see that indeed PromptStealer performs better both in the terms of prompt and the images. And from the perspective of the quantitative metric, PromptStealer also achieved better results. We also did a lot of ablation studies. So for example, we try to apply PromptStealer on Midjourney and DALL-E 2. And the generative images are also good. And we also noticed that there are some like vision language model right now that they can be used to predict prompts. So we also compare a popular prompt generator, which is a GPT actually. So we find that PromptStealer still outperform it. Basically, we are better at recognizing the art style. And of course, we care about the mitigation, the defense of the attack. So when we look back at PromptStealer or any other baseline methods, we find that they all rely on machine learning models. So a natural idea is that probably we can reduce the performance of these machine learning models. So one possibility is that we can add some perturbations on the target image, and then we optimize it, right? So our goal is that if we add these perturbations, then we hope that the model can predict some wrong modifiers. Especially we want that it cannot predict the artist names, artist modifiers, because we find that artist modifiers usually play the most important roles in the stolen images. And also we want to protect the copyright of the artist. So we call this method prompt shield. Yes. So here's the results of prompt shield. The first line is the original image and the PromptStealer's performance. You can see that they are it performed good. And the second line is the shared image, which we add the optimized perturbation on it. And you can see that PromptStealer, indeed, it performs bad. The stolen images are very different from the target image. Yes, so here comes to the conclusion of our paper. So this is the first study on prompt scaling attack, and this work has already been recognized in Microsoft Vulnerability Severity Classification for AI System. And PromptStealer outperforms baseline methods both quantitatively and qualitatively. And we also make the first attempt to mitigate the prompt scaling attacks by proposing prompt shared. Yeah, that's all from my side. Thank you for listening.
Okay.